Welcome to the Planar 2020 webinar, first one that we've done so far. We do a lot of web demos here in this room, but now is kind of the first time we've decided to get together and actually discuss the software in kind of ways that we've had improvements over the last couple months here. As you can see here, the machine in front of me is probably different than most of yours. This is our all-in-one machine. I've got the 2D, I've got the surf scan, which I believe most of you have, and we also have the 3D off here onto the side. Today we're only going to be covering most of the 2D. If a couple of questions pop up with the surf scan, we'll cover that. But we're probably not going to touch the 3D today. We'll probably make our own webinar about how that works. So first things first, let me get zoom into that. We're going to kind of cover some file open options here. Again, with tips of the tricks and trades that I've been doing with you guys. I installed a lot of your machines, but we also did not cover some things that I've learned over the last year or two. So for instance, a lot of you are currently using CAD models and planar files to work on. One thing I didn't know that I just learned about the last couple of years is what you can put in this auto import dimensions thing. If I were to import a CAD model with nothing in there, and as I hit open, it's going to select every layer possible. Whoops, it's going to select everything I used to have. Just select all these layers, and there's a bunch of things I don't want in there. If you guys know your system, you know your naming options, you can actually put just layer 0 in there, and it will actually default to that layer when you first open it up. So it only opens layer 0. Then I can go in and I can change it to grab different layers if I want. But if you know you're going to have layer 0 or layer 1 or flat, whatever your names could be for your flat layer, you can put all those in there, and if the CAD model has it, it'll automatically select it for you. So just something useful to when you guys are opening CAD models to constantly do it. So in this case, I like 0 and DIMS. And if I save that and load in a CAD model, it's going to automatically select those two layers. I don't have to do anything else. It's everything I want. I hit OK, and we're done. So again, something new. What we can also do in here is the collection arcs and collection of rounds. Now, I believe I preach with you guys that we should always turn that on. It is so useful, so helpful. Worst case is, in this instance, if we were to import a file that has a slot in it, for instance, all right, might not be extremely useful for a part like this, but it's nice to automatically get those collection points. And as I discussed in the update email that I sent out to you guys for the webinar, we can actually now do collection points automatically generated with a click of a button and get the XY locations from a datum. So to make it easier for you, if you'll turn on collection arcs, collection of rounds, it'll automatically put the center point in the center there. We can go into our inspection report manager, say automatically generate my XY location from my datum point, and we did every slot that's on the part in a matter of seconds. And then same thing for those that use collection arcs. I have a kind of a program set up here to show off the arcs. And again, leave it selected, because worst case is, maybe you want to grab this nominal where all these arcs have the same center location, so it created one diameter for you. I could grab location of the center part. I could grab the diameter. I could also grab true position off this collection circle. All that is now useful that I can now program into my CAD model. So another thing that most of you hopefully should know is these black arrows in the software with the down arrow on here, you can actually right click on any of these, and it's going to bring you right to that specific location in your edit options. I know a lot of people kind of get comfortable with just going edit options, and it just defaults to the CAD file open. But if I know I want to change my inches to millimeters, I can right-click on Measure. It'll bring me right to the Measurement tab where I can change it to inches or millimeters. And actually, in the Measurement tab is where we're going to stay right now. A new feature we've turned on in 2020 is going to be what's called Ignore Measurements Near Endpoints. Now, what those will do is it will actually get rid of data around an edge. So let's say, when you guys cut parts in the laser, a lot of times what will happen is these will be 90-degree cuts. The laser is still going to round off just a little bit of an average around that radius. Now we measure that and we round it off even more. We've got compound rounding going on, and then your part sometimes fails in the corners and it drives people nuts. So instead, you can actually turn on Ignore Measurements near endpoints, and we can set up, I'll say maybe 10 thou. I say I don't want anything within 10 thou of the end because that data could be shifted. We can now say it. Turn that on, it's going to not use any measurement data within 10 thou, and your numbers should hopefully look more accurate instead of using that compound rounding. So, also, I've had a lot of people send me emails about, what about this number of objects? 0 equals unlimited. I want to run 5 parts. Do I have to put 5 in there for a value? No, that number should always be left at 1. Sorry, 1, 1, 1, 1, 1. 1 is just how many parts we're going to measure. The only time you would change it is if you need to reverse engineer multiple parts. Then you could say, all right, put 0 or 3 down because it'll just give you the 3 biggest blobs. But if you set it as 1 and you use auto inspect, it will always, always, always measure any part that looks relatively close to your CAD model's area. So leave that at 1, only change it to 0 if you're looking to do some reverse engineering. And if we're actually going to cover some new tips on reverse engineering as well today. So feel free to ask any questions about that if you need it. And again, clear scene is always nice to have on because when you measure a part, you want to get rid of old data, and that's what clear scene is for. So just leave that on. And we're going to stay in millimeters as well. Now, inspection reports. Nothing really changed in here. There is one thing that's new, this use drawing and timestamp as report name. Now, that button's not inherently new, but however, it does actually do a new feature nowadays. What I can do is if I turn on use drawing and timestamp and I have save planar file in the auto inspect button turned on, it will actually save a planar file in the exact location of the root master file with today's timestamp on it. So for instance, if I save planar file and I go load up the 2D demo part, .planar, I'm going to measure this. And what it will do is actually will save another 2D demo part .planar file with the timestamp of 10:11 at how many seconds, just like that, and save it in the folder for you. So this is kind of a backup way of doing SPC. I would recommend SPC is still a better option, but if you guys want to back up planar files and know when they ran it, and you want to go open that to view it later or something like that, this is a nice and easy way of knowing that. If you turn on, again, turn on the use drawing and timestamp, as well as checking save planar file, it'll now automatically back those up constantly. I would ideally recommend you do that for maybe if you guys are sorting your parts in a per customer folder or something like that, because otherwise, if you have all of your planar files in one folder, it could get a little messy seeing nothing but that, and it'll just add timestamp after timestamp. So that's a nice little one for those that want to save the planar files. You can turn that off for now. Another thing that we'd like to do here that most people don't, I guess, is report logo path. If you want to show off that, you know, your company made this part and inspected it for this customer. Let's see, well, having a saved file for my data, would I need this? Would you need it, Christine? Having a saved file for my data, no, it's actually more of a backup option. It's not going to be like a new master. It basically saves it as like, all right, we know that operator Joe ran this last Tuesday because we have a timestamp of that part number with the timestamp of the time he ran it. That's kind of the idea of it. Certain customers that kind of do a lot of constant running and running want to know what their operators are doing. They actually have them save planar files, but they don't like that you have to manually direct where it's going to save to. Because if before we had this option to report the timestamp and drawing name, it would always ask you, where do you want to save that file at? Then you're relying on the operators to do it, which, well, sometimes we don't like our operators having the power of where to save something, because if they do it wrong, you lose your data if that's what you're using for that. So that's the idea behind this, is just making it easier. But then again, you guys can always go in here and change your logo for what you want to be on your inspection reports. For instance, we got, you know, productivity quality starts here. You can put that on all your machines. I believe most of them default with the InspecVision logo. But if you guys want to change that here, a lot of people don't know that you can change that logo right there. And an interesting one that started to come online as well that people are starting to like is check inspections. The idea behind check inspections is that our machine is not perfect. Technically, any machine you use to measure something is not perfect. There is amount of uncertainty included that makes you, you know, not sure within a certain value of the part you're getting. For this instance, if I turn on my check inspections to 0.3 millimeters, and I were to refit this part and take a look at it, you're going to see that the part turns yellow on the table as well as highlights yellow here. That's telling me that they should check this part because it doesn't pass, but it also doesn't fail because it's within 0.3 millimeters of passing or failing. Now that's a pretty big value, but I just had to find something that, you know, would kind of show off this value. And if I go into my inspection reports and take a look, it actually highlights everything as passing except for that feature where it'll highlight it as yellow and the status becomes check. The idea behind that is if you have very critical diameters, and our machine maybe isn't fully capable of holding a ±3 or ±5 for your diameters, you could turn on ±5 and say, if it's within a thou of that, don't fail it, turn it into check, and I can go in with a pin and actually pin it to see what it truly is. So what we recommend for putting in that instance is normally the machine accuracy. So for instance, this is going to be 0.0138 because that's the machine accuracy in inches here, or 35 microns in millimeters. But you can actually put in any value you want for your parts. No rules on that. And automatic inspection. So this is how most of you guys run your parts. This is how I train most of you guys to run your parts. And nothing's really new here. The only thing I wanted to bring up is the idea of the auto-gen report. I don't really train you guys to do it because I know most of you guys load in the CAD model, save a planar file after that, and then you have your operators load the planar files in that you've already deemed necessary. But there are certain shops out there that love the idea of turning on auto-gen report. And I can now go in here, and you'll see a bunch of extra auto-gen options that we'll cover later. But I can say I want the distance XY of my circles, and I want the size. Let's say I only care about my diameters for this part. If I leave that checked and I actually open up just a generic CAD model, I go back to my 2D demo part drawing file. I've got no items in here at all, no inspection items. And when I measure this part, it's actually going to generate the report for me. Now, most of you guys are probably using bubbles, and you have to try and fit, dimension 1 to bubble 2, bubble 1. But here's another way of doing it. And you see here, I now have 66 dimensions that are used from my nominal point. And my datum is going to be Y datum is here, X datum is there. And then it's able to calculate your diameters as well as XY locations of all those holes automatically. So I didn't have to program all that in there for me, those 66 steps. It just happened on its own. Again, kind of fun. That's only for if you're loading in drawing files, though, or DXF files. If you're using planar, just run the program and save it as a planar file, and then turn off the auto-gen, because that's not going to be helpful for you. And then output SPC, we'll be talking about that a little bit later as we talk about options for that. Let's see, turn off. Oh, yeah. So another thing that people do when they run programs, most of you guys see this, we see in the surf scan, that's given us the ability to project green onto the part and give it pass-fail status. I've actually found a couple different ways of running things that kind of some customers really do like, is to actually turn off the deviation map. Certain customers out there don't really care about the passing or failing, they just want to see actual numbers. And a way to make it pop up and say actual numbers quicker is to actually turn off the deviation map. Now the downside is it will get rid of the green onto the part, onto the table here, but what it will do is it'll bypass just fit it to the CAD model. It won't care how it fits to the CAD model. It'll actually just give you the inspection report straight out, and if everything's green, you know it passed, and if it's red, it failed. And that's it, it's done. That's what it looks like when you run it without the deviation map. I do have a couple of customers that love this because they actually wanted their operators to take note of certain values. They need to see what this number 3 dimension hole is. They need to see what the overall deviation is here. So different ways to run it. Now again, you kind of lose the cool ability of the surf scan displaying green onto the table. But if all you care about for your specific, methods of measurement is the true dimensions, you actually can skip the steps of teaching the operators to go into the inspection report and double click on the first value and then finding things from there. You can just use this diagram view and look at it from there. So another way of running the system. Next, we're going to kind of talk over some component properties. Most of you have been using the newest version of software, but those that have maybe been working with, I actually worked with the customer last week that had 2015 software. So there's definitely some people out there that don't know all these new abilities. And one of the new ones I want to show you is this adaptive ability. Adaptive is a new one that came out in 2019 software, and they didn't really tell us much information about what it is. They just said, when in doubt, why don't you just turn on adaptive and leave it from there? Well, adaptive is basically a way that we can actually adapt the machine to your part. The idea behind this is I'm going to go and measure this part at a CMM. I'm going to know exactly what the values are on a very high accurate machine. Then from there, I can come over here and measure it on my machine, and I can see my offsets. I can see, are the overalls measuring long, are the diameters measuring short, vice versa from there. I can now use a value in adaptive and the values go from +1 to -1. And I can go like, all right, I want to go 0.375, right? I can put that value in there, and maybe that'll help me get closer to the CMN values, or maybe it goes worse, so I need to add a negative to put that closer to the CMN values. And now we basically comp that part in this machine to the CMM and know that our values are going to correlate very well. The downside to this is you have to almost do this with every part, which is slow. But the upside is now you're correlating your data to a very, very high accurate machine, and you know that the parts you're getting in this machine, if they truly are out, they've now changed from your master nominal, and that's why they fail. So adaptive is there for that reason. When in doubt, if you're ever going to use an adaptive, just leave it at 0 so that we don't change any numbers. But if you guys want to go through, you could use adaptive in that way and actually change it per program. So then what I do there is, let's say this part passes better with 0.5 adaptive value, then I go in and grab this part, and then all of a sudden as I run this, I know that maybe 0.125 runs better. And you just have to save that in the planar file as the adaptive setting, and then you're good to go from there. All right, so that's what the adaptive does. And another thing in the 2019-2020 software is going to be the radial snap settings. I believe, I know most of you guys that are in this chat, and I believe most of you don't do any radial parts, but the only thing that has changed in the last year is this radial search option. It'll actually let you rotate a part 72 iterations around to try and fit the best method to the part. All perimeter with optimization is always what I teach you guys to go to. That's going to be the fastest and most repeatable number, because it'll always make sure it snaps to the right way. However, with like motor laminations or something very circular, it might have a little notch out in the top corner that it just doesn't see, and it fits it the wrong way. With radial search, it'll almost, air quotes, almost always get there for you guys. However, I don't want you to think that that's the best option on every part. Radial search should only be used for very symmetrical parts that maybe need to be flipped or rotated to fit better. Otherwise, you always use the all perimeters with optimization, and that's going to go a long ways for you. All right, deviation map. Now, for those that do have SurfScan, you know what the deviation map does. It's this grid that's displaying this lovely sonar, radar, whatever people want to call it. People want to play chess on this thing. This is our SurfScan, and this projects deviation back onto the part. When we measure a part, for instance, we can have whiskers, we can have a blob. Now in 2020, what they did is before, they used to have a big giant green blob that fit around the part, and it was actually bigger than the table. And if you were to put 3 parts next to each other, it would actually cause interference, and you couldn't tell where the part passed or failed, or which one passed and failed. And they also had numbers on top of the part that made it really hard to tell. Now in 2020, what they've done is they've actually zoomed in to the part, and wherever you have measurement data, that's exactly where the blob is. And if I move this part to the bottom right, you can now see that I have missing data here because that's where the hole should have been, and all these squares have their own missing data, so it highlights exactly what your CAD model looks like for material and puts it on the table. The other benefit to that is if I run 2 or more parts, it'll now highlight, let's see, I need to find a passing one and failing one for you guys. There's a bad one. It'll now highlight the table with numbers as well. And those numbers will be see-through, so you can actually see the dimensions that pass or fail, and the numbers will be color-coded for pass or fail as well. So snap 1, snap 2, snap 3, and there we go. As you can see on the table now, we've got part 1, part 2, part 3, and we now have a red number 3 to show that that one failed, and red number 3. This guy used to be constantly pink, which is really hard to see. Now they've changed it to an outline, and we can still see our dimensions to show that that is missing. Again, those that have done demos with me know these parts, know that we usually just plug a hole to make it look good. But those numbers is now a new thing that they've done. And what we actually did before is we have this bag of O-rings I'll cover in a second. I put all 25 of these on the table. In a matter of seconds, I've got them numbered, and I can just go grab number 3 and number 18 that failed and know that I'm ready, versus before you'd have to sit there and look at it again and get a better look. Is that the one that failed? How do I tell? You know, these numbers make it a lot easier if you didn't know what you're looking at. And it kind of looks pretty as well, which is, you know, goes a long way. along with the whiskers, so this is like the blob, and then, people maybe want to look at whiskers. I'll set that to 40x. Whiskers can be good and bad. I personally feel like the whiskers should only be used for quality managers. There's not really a reason. Let me remeasure this so they fit better on the table. Did they update the deviation map to actually show the parts like they are on the table? Scott, I believe that's a yes, but do you want to add more information on that? What do you mean by did they update the deviation map to?
Well, one of the things we had when we were looking at this machine is see how on your report they're not orientated in the same position as what they are on the table. Is that still the case? You know how you got 1, 2, 3 left to right, all horizontal, but then on the deviation map up top, I guess you have the numbers on, so that's instead of reorganizing them, they thought that that would be the better case so you can still kind of identify them. Is that kind of what they're trying to do there?
Yeah, what they do here is however many parts you have, they just kind of put them out in the best grid possible. So in this case, let's go to the bottom left is 1, just like you normally would on your graph of your table. And here's my machine 0. So then they'll have 1, 2, 3, and if I would have put 4, 4 would go there. And if we had 5, it would do another row.
So they're just trying to optimize the layout?
Exactly.
Basically. Okay. And
actually how these machines measure the parts here, it's actually from this side up is part 1, 2, 3. So I can make this inverse, and I can now make this one part 1 because that's nearest to the operator. So once you kind of learn that, you actually kind of know the idea behind the machine as well. They also did actually update the inspection report, which I'll get to in a second here, to also help with these running to multiple parts, because that's one thing we love about this machine is it's so easy to run multiple parts. And that right there is why I also don't use radial search. Thought I'd turn that off. But you'll see 1, 2, and 3. So it's the nearest 1 to you is going to be the first one, and then it just kind of goes from there. Whoops. So back to what I was saying, the whiskers and the blobs, I personally I was using the blobs for operators, and whiskers is going to be more for the quality managers. The reason being is whiskers actually tells too much of the story of the part, and it gives your operators an idea of, I can see what's wrong with this part. I think I'm going to fix it for them. Well, no offense, I don't think we want that to happen, though. We want to be able to see that this part looks a certain way. For instance, I can see that this slot in the top right corner probably should get pushed in the X positive direction and Y positive direction because all my data is is kind of going left and also going down. But you don't want your operator to see that because he might take liberties in his own actions and thinks he's doing you a favor. So for those reasons, I always leave just the blobs onto the table, and then they can, if you have a question as a quality manager, you can dive into it and fix it from there. And the last but not least, a little thing that people always don't realize we can do with a surf scan, sometimes you run a part and it keeps these colors onto the table for you. Well, sometimes you want to run another part or leave it without that extra data behind. If you guys want to get the sonar grid to pop back up, little tip for you, go Calibrate, 3D, project field of view, and now we've got our lovely grid showing you the center of the table, and I usually use it as my nominal for where to place your part to get the best results. So that's another one that most people don't know. Again, that's Calibrate, 3D, project field of view, handy to help get there. Just want a quick touchly on O-rings as well. I don't think much of you in this chat actually use O-rings very often, but in case they come up, we can very quickly and easily do them without the use of a CAD model. Computer vision, measure O-rings. You can actually go right here, and I can type in, I've got my O-rings here, and I've got a little sticky note telling me what values I need to enter for these O-rings. And it is a cross-section diameter of 70 thou, and the inside diameter is 0.801. So all you have to do is hit OK. Hold on here. Completely forgot. I am in metric. These O-rings are in inches. There we go. So computer vision, measure O-rings. That's everything I wanted right there. There's my nominal. There's my dimensions. Put the part down, and it creates the CAD model for you. And the nominal is also pulled in from the cross-section because that's how O-rings work. And then if you wanted to, you could also do one of these things where you put a bunch of them down, and it's Very fast and easy to just measure constant O-rings, boom and boom and boom, just like that. And again, this is where the part numbers come in. If you guys do a lot of sorting jobs, you'll see actually here, let me zoom in for you while it thinks. Kind of hard to see on the camera, sorry, but you can see that we got part 1, 2, 3, 4, 5, 6. And if any one of those failed, I could just go grab part 2 and 3 and know that the rest are good. So again, I really like that new feature. I didn't even know they're going to come out with the numbers, but they do really help. All right, now let's get to the fun stuff. GD&T, alignments, inspection reports, all that good stuff, probably the stuff most of you guys are here for. So what Planar has done is they have completely revamped the way they did GD&T. Like I said, when I started up the conversation here, I had a lot of disgust with how they initially set up GD&T because, oh, look at that. Forgot to turn off that guy. And that's what happens if you guys keep the drawing and timestamp on. It just keeps adding to it, which I did not want to do here, by the way. So I did not like the old way that Planar did the GD&T because you have to do a linear dimension, change the linear dimension to a true position, change the tolerance, change the global alignment, and those global alignments weren't technically a datum frame, so they weren't true GD&T. They were basically datum simulators, but they weren't correct. That has now changed in 2020 Planar. If I go to my inspection report, oh, sorry, let me load up a model here for you. If I go to my inspection report, we go back to the alignments tab, that has not changed. However, this whole alignments tab has. We've got options to do it the old way, where you could have a bunch of specific features you wanted to align to, just for alignment-wise, or we can now construct datums in our frame here. So for instance, let's say we have a true position on this hole. I think I have a generic, nope, I thought I had a part here to show you. But let's say I have true position on this diameter that's set to an ABC datum frame. Well, before we were never able to do A because you couldn't really use A, it's just assumed, which is still the case, but we can now simulate datum A. If I say click, add, it'll say select nothing to designate the bottom surface. That's usually datum A. So if I right click and add nothing, A now becomes our bottom surface. Next, I come in here and say that's going to be my datum B. That becomes datum B. And down here, that becomes datum C. Now for your shops that use, I know a couple shops that use X, Y, Z as your datum frames, or if you need to change exactly what they are, just double click on this and set that to, you know, X, Y, or Z, or whatever you want, and you can change the datum name from there. Now, we technically haven't created an alignment, we just created datum features. So now from here, I can go back to add, and datum frame becomes an option. I can now specify how I want to build my datum frame. Do I want for instance, I want to make an ABC alignment. Boom, just like that. We have ABC specified. I can also add another datum frame to only specify B and C. I don't want to include A in there as well. Now I will add that this doesn't work with complex or compound datum structures. We can't do true position off of a bolt hole pattern with max material condition as datum B. That is too complex for 2D software like this. There's software I will show you coming up here that can use measurement data off this machine, and we can do very complex datum structures. This software can't. The best way to do that would still be add a best fit alignment, and you just want to say, you know, let's say you care about these 4 holes for some reason. Maybe they're actually not even a bolt hole pattern, but you wanted to use those as your best fit alignment. You could make a best fit alignment based off of that to, again, it's not a technical datum frame, but you can try and do your best to get there. That's basically the old way that Planar was doing their files. So now if I go to a new report and I go to manually add, on the bottom right here, for those that currently have a Planar, you'll see in the bottom right we have all these new GD&T features. These are now buttons we can use to actually calculate what you want. For instance, the tried and true position. I said I want true position to this hole here. Click on that hole, I can draw a leader line exactly how I want it to look. And I'm going to put a value of 0.5. And now I can also do the material condition. Again, something we were not able to do in 2019 software. So now I can specify I want the MMC or max material condition of that hole. But in order to do that, I need to know the diameter of that hole. But it knows that. So I click on that, it's going to automatically pop up and say, all right, give me your diameter tolerance. I type in 5,125 millimeters. Hit OK. And now I can also specify which alignment I'm going to use. A was my global best fit to those 4 holes. ABC is what I truly want, so I'm going to select that one. And when I hit OK, you can see now we have a diameter callout and a true position with a leader line that looks like true position, just like your prints. And when I hit done and back out, there's your value for what the actual value is. Now the tolerance was 0.5, but we're at 0.526 and it passes. What's up with that? Well, because we're using the max material condition, for those that know GD&T, we gained a bonus tolerance of 0.107 because of the diameter. So it does include the bonus tolerance in there for figuring out those dimensions. So that's a true position. We can do the same thing for profile of a hole if you want something like that. All these are now selectable that you can actually draw them out and get those features on it. I can do perpendicularity. I want to pick that line. I can draw that one as well. And that's automatically going to select my datum B because that's the only datum that is perpendicular to that line. Same thing over here. If I do, let's actually do parallelism. I want parallelism of, oops, helps if I select the right one. Parallelism of this line. The only option it's going to let me pick is datum C because that's what it's parallel to. And when I back out, those are all the features on our report, on our print, and they actually look like the value that's on your guys' inspection report. So I'm very happy that they finally changed these to no longer be just straight dimension with true position formulas. But that could be a little time consuming to have to sit here and automatically, hit true position on this hole and then draw a leader line where you want it. And then, yes, I want MMC, tolerance of, again, 0.125. All this takes time. Luckily, they were smart enough to add true position into the auto generation features. So I'm going to go create a new report. I've still got my old alignments in there. And I'm going to go auto gen. And here you're going to see a mass extra, not I guess, I shouldn't say mass, but there's a lot of extra features here which are very, very, very helpful. Certain customers ask for, hey, I want to know just the X distance of all these holes because my X and Y have different datums and I want to do that at different times. Great, we can now do that. I can say I just want my X distance and it'll let me select a datum. It'll give me all my distances from there. Same thing for my Y. I can do that. Before, I'm not even sure if some of you even knew this, but before, when you were to say I want the arcs, it would actually output the location of the arc and X and Y and the diameter, which is not what I wanted. I just want the size. We can now do just the size. But position is also now auto-generatable, and I can say I want all my diameters to have an MMC callout to ABC, hit done, and we now auto-generated all 28 holes, I believe, are on this part, and we're done. And you can see there's the diameter and there's the true position value. If you really want to get what you guys are probably looking for, which is true position with the XY location, because maybe that's something you want to know as well, do circle with position to MMC to ABC, hit OK. Again, select my datum point. I'm going to specify that's my C and that's my B. And now from there, I've got, as I start down, this is my X location to that hole, my Y location of that hole, size, and position value. Next one is going to be, again, X, Y, size, position. X, Y, size, position. So they've changed up the way that they actually make the inspection report as well. And in my settings here, I can actually specify if I want numerical values for what the feature names will become, or if you can have alphabetical names. Actually, I've been fighting them for probably about 2 years now, where I really disliked that after you get to 26 dimensions, your item names become extremely confusing. You get to 80, 90, 100 something dimensions, you're now looking at dimension 3F. I don't know what dimension 3F is, but I know that's supposed to be dimension 87 on my bubble print. How am I supposed to know that? Well, now you can actually change it to 1, 2, 3. It's going to be a lot more easy to just go straight down to dimension 85 and go see what that looks like instead of having to look for it in a different way. And now it can also match your bubble prints as well. So for the same thing, I actually want to show you guys a couple other advanced features as well that I've been learning over the years. For instance, one of them is going to be rotate a alignment of a dimension. I have a call out possibly. Let's say I have a call out where I want to do a distance from the axes of this line in correlation with this diameter. In other words, I want a direct distance along the axes of this line. To do that, we actually can, which some of you might not know. I'm just going to construct a vertical distance. I can now do a command called rotate, where I'm actually going to rotate this dimension. I'm going to rotate it from the center point along that axis. And now I can grab this endpoint, recenter it, and now you'll see this dimension is now aligned to the line over here. And that's the dimension you truly want, is along these axes, what's that location? And just like that, we can see that value in the software. That's one I believe I taught some of you, but not everybody was aware of that by the time I finally learned that a couple months ago. So that's a handy little one. As well as if you guys are trying to dimension manually because you have a lot of internal features that AutoGen maybe isn't as useful as you'd like it to be, what we can also do is I try and teach. Turning on and off your snap settings over here is going to make life a lot easier. If I know I want to use this as my 0 point and do a couple XY distances from there, I can actually turn off my endpoints because I know I'm never going to use endpoints, and I can turn off perpendicular. So if I go 0 here and down here, no matter where I go, it's only going to snap to the mid of those things, and I can fly through this a lot faster knowing O snap center, boom, and boom. Before, if you ever leave the endpoints on, it can be a pain in the rear if I do it the opposite dimension, because sometimes it wants to snap over here, sometimes it wants to snap there. It can snap to the end of one of these boxes. So ways to making life easier, again, is turn off the O snaps, knowing what you're going to measure, and then from there, your life's going to be a lot easier. Another thing that we've changed, now this is what the planar InspecVision likes to call is not a supported feature, but I'm going to show it to you guys because I think it's extremely great, and I'm trying to encourage them to keep it for this build. If I create a collection point at the center of this feature here, I can actually use that collection point and calculate the profile of everything made from this collection point. So if I have a call out for the profile of this rectangle slot, I can now do a profile call out to that guy. And I'll call it, 0.4. And when I back out, that is now the profile of that entire slot held to that value. Before, what you'd have to do is you'd have to actually manually go in and say, I want profile of this feature there, and then do it again, and do it again, because you can only do it per feature, which is slow, and then your inspection report gets crazy busy. But just to prove to you that I'm doing the right thing and it's not fudging the numbers here, I'm going to put all 4 of these on here and show you that the worst case of these 4 numbers are going to be the 0.442 as we see there, and just like it is there. We got 0.442 and 0.442. So they're on top of each other. A third way we can do profile, if you want to do something easy, like the external profile of a part, for instance, we can actually go in here and go to the Tolerance Zone Manager. This gives us the ability to do what's called a whole perimeter of a feature. So if I click on whole perimeters and hit edit, let's say I have a 1 millimeter tolerance around the entire external edge of that part. I can click on that, and now I can say I want the GD&T profile within 1 millimeter. So that will allow basically the worst case deviation times 2 is what the profile is there. So I get up to 0.5 millimeter variation because that times 2 will be a failing profile. And if I click on Deviation Map here, as it displays that, it'll now give me that value to show what passes and what fails. And we can see 0.737 is what fails there. Now, I will say for those that get the 2020 software that update it, just know that I found out, I'm not sure if it's on purpose or not, but if I uncheck deviation in my inspection report method here, and I were to hit this again, it only shows fail or pass. It won't actually show you the value. So to make sure you see that, you just got to make sure you have deviation checked in there. Again, I think it's a bug, but in case it's not, and you ever see fail or pass, know that that's the reason why. And you can now print it out in your diagram, and you've got the report there. I can also add multiple ones and have different areas set up. And I can say I want that guy to, again, be within 0.4 GD&T profile. And as I hit exit and refit it, there's the value down there, 0.415. And it shows the profile callout so you know what you're looking at. So again, ways of making the software look better and true to the print, which is what we're really trying to get to these days. Tolerance tables. Most of you that I've worked with don't like tolerance tables. You don't use tolerance tables, which is completely fine. I get that. Every customer, every part number is going to be different. And for those reasons, we don't like to use tolerance tables. But they can be very useful if you have something that's extremely, repeatable, the same part over and over again. I've worked with customers that have had some tolerance tables for the part like this, where they said anything that starts with an external dimension, which would be like your datum reference, that would be 0.5 millimeter tolerance, or set that up as a value. And any internal features will be tighter because now it has to fit within each other, and those can be a different value as well. So you could use tolerance tables like that. You could also use a tolerance table to say, if you have a diameter that's a quarter inch or less, it has 5 thou tolerance. The bigger the diameter, the more tolerance you get. So then maybe you get up to 8 thou tolerance on 1/2 inch or more. Different things like that. You can use the tolerance tables to set up for you. And planar files can be saved with the tolerance tables, and then they can run that way as well. So you can use them if you want. Don't use them, but just know they are there and they are helpful. I've helped quite a few customers with those. And user accounts operator mode. Very few of you guys use this because I actually didn't know much about this in the last year or so. Operator mode can be enabled by clicking on the user down here as default. So for instance, if I want to start operator mode, I know that I titled it operator mode and my password. Helps if I type mode properly and type in password properly. There we go. I'm now in operator mode. That gives me the ability to inspect a part, review a part, but I can't modify or add dimensions. So if I want to hit manually add, it's going to pop up and say you have to be an advanced operator to do that. This is a way of kind of keeping certain operators out of the ability to modify tolerances, changing inspection reports, deleting a feature that maybe was critical, but they just did a sly, hit delete key and move on with it. So a lot of you have never actually set this up because I probably didn't teach you. But to log back in as an advanced user, I go admin, and I'm back logged in as admin, and I can now go in and say, hey, all right, I want to go in, modify, manual add. And when you're done, you can log back into operator mode and then leave the operators at free rolling. So again, operator mode is just kind of handy for certain customers that need it. Let's see here. Measure multiple parts. Reverse engineer. Some of you guys have been doing it. Some of you have not. Reverse engineer did gain a few new things in 2020, and that is going to be something called the grid array. See, with a polar array and put my mouse on it, rectangular array. So in other words, this rectangular array, which is right here, I'm going to set up a diameter right on that guy there. I can now do a grid rectangular array with that part. Now, I know about this part, so I'm going to make this look easy, but you have to maybe probably do some dimensions to figure it out. I want 4 rows by 4 rows. So I want 4 rows and 4 columns. Distance between rows. Now, I know this is 15 millimeters. You probably would have had to have measured that out. And what I did is I measured distance from here to where I want this one to start. That is 15 millimeters. And same thing for columns is going to be 15 millimeters as well. And just like that, let me turn off my measurement data so you can see it. There's my grid array that it automatically pasted over top of that rectangular array. Same thing, if I want to do a polar array of that rectangle, I can do the same thing and say the center is going to be at the tip of that guy right there. I'm going to go 12 items in the array. Angle of fill is 360. Rotate objects, yes. Whoops, didn't do that one right. Probably should have said less on that. But now we copied that off. If I would have done it right, it would have done like a nice polar pattern of those rectangles rotated properly to be pointing towards the center of that array. And that's kind of how it works. Kind of nice. Not exactly required, but new features that I know certain customers you guys did use. Only other option I'll give you guys here for that are doing reverse engineering is something I didn't use until last year, and it's called this use snap fitting. If you're actually doing reverse engineering and you want to make sure these diameter locationally get within the same value of each other, I'm going to set this up to 0.5 millimeter and 0.5 millimeter. That will let me construct a diameter there and there, and they're going to be within 0.5 millimeter of what the location that they're in. So now if I were to go over and say, I want to know the location from that guy to that guy, it's at 226 exactly, right? So that's going to let you kind of finesse and make those reverse engineered reports a lot faster, and knowing that it's going to be roughly around that same value. Because if I turn off snap fitting and I delete everything I just did and I do that again, you're going to see the numbers look completely different because they're just going to round down to the nearest like sub-micron or something like that. Again, center to center. Look at that. Now it's 225914. So if you turn on the snap fitting, it'll round it up for you to get within the nearest 0.5 or 1 millimeter. It's up to you. So different ways of using things fast. And you can also turn on use snap fitting and do max fit, best fit everything. And now all this stuff has been averaged out within 0.5 millimeter for location-wise. And that's what the ideal is behind that. Now, last but not least, and then it looks like we'll go over questions if you guys have anything about GD&T or anything like that. SPC software and outputting SPC or CSV files from the planar machine. Very few people, well, I shouldn't say very few, not everybody in the fab world sees SPC, that is statistical process control. Not everybody sees that as a very helpful thing. I hope that we can start to change that mindset because it's so easy, it's so nice to have. What I can do is I can output the SPC of this part, and I've got 32 dimensions on here. Helps if I put a part on the table. Put the part on the table, and if I have the software called QC Calc. QC Calc is going to serve two purposes. One, it's going to give you easily red-green numbers to see what passes and what fails. So if I measure this part, go ahead and delete all my old data. All right, I got nothing loaded up, and when this guy runs, I'm not going to paste that data. QC Calc will grab that data and display it just like this. Now, if I were to run 3 parts on the machine and keep that original data, I'll flip this over so we get something a little bit different. Hit measure again, and the same thing. It's now going to see 3 parts, add that to what I currently have, and now you'll see 4 blips of data, and it'll fit it and go 1, 2, 3. And this gives you a way of kind of tracking and knowing where your parts are at on this machine. You know, we can look at this part here and say, this is really close to nominal. Our CPK is 5.76. That's a really good feature. We're doing that well. However, this guy over here is always at the lowest tolerance, and we're just barely passing this part. Our CPK is only 0.6. Maybe we should look at why this feature is always failing or why this feature is a problem for us. And that's the value of QC Calc real time, is taking your SPC data. If you're going to run this machine anyways, you can keep this in the background. I can run all these parts 5, 6, 7 times. Actually, I can even do that right now. Throw a bunch of extra features on here, and I can hit go, and it can just keep running and running and running. And by the time I finally care about it, you guys can just go open up QC Calc, and it'll automatically grab these files. And it'll just update your database for you when you finally get around to actually starting up QC Calc. So just like that, a bunch of fails, a bunch of passes. It's a mix match. But if I open up QC Calc, it hasn't grabbed that file yet, but when it does, it'll just paste the data for us and then sort them out. There it goes. Found the data, and then it sorts it for you. Last but not least, the other benefits of QC Calc, besides just doing real-time analysis and CPK, or we can also change the displayed calculation from CPK to a range or a sigma, average, whatever you want in that part, and you can run it that way. But we can also help you guys do your FAI reports or your FAIRs, your PPAPs. If you guys have a generic Excel file you guys always use where you have to export your data, copy paste from a CSV file into an Excel file, put your own logos, put your own names on it, and it takes all this extra, 15, 20 minutes of work, we can actually do that for you using this guy called Office Buddy. Now I'm hoping we can keep up. Normally it's faster than Excel can load, but it's going to load Excel, and I'm going to start up a standard first article inspection report. We have a couple generic ones in here as well, an AS9102 that we can start up for you. See if I can hit load before it runs. There we go. So it's going to auto-populate all this for me. There's my nominals, there's my tolerances, and there's all my measured data for that part. Now we can go through and see where we've got bad data or no data, and we can go on from there, and I can save this as an Excel file, or sorry, as a PDF or print that out, and we're done. So instead of having to export this data manually and copy paste it in the view you want, you can set this up ahead of time and go from there. So just a nice little add-on. I think that's only like $1,500 these days. Not much for what you could potentially gain to know what your part's doing. And last but not least, for those that have some really complex GD&T, I know there's a couple of you out there. Some of our software just isn't good enough for what you need to do. If you have, like I said, if you have a bolt hole pattern held to a maximum tailor condition, and that's going to be your datum B, we just can't simulate that. It's nothing planar can do. Not to mean that you're completely hosed in the water, though. I actually had this software called Smart Profile. I believe we've done a demo with some of you guys on what the software can do. And we have a macro that we've set up for Smart Profile to show you guys exactly how easy it could be. And Smart Profile actually runs the planar system. So I'm going to take everybody off but just one of these guys, because where I'm going to hit play on a script, and it's automatically going to measure this part with GD&T print and everything from there. All right, hit load. You're going to see planar pop up here. It's going to take a photo of the part. All it's doing is taking a photo because we don't care what file we're running. We're going to basically close planar after we take the photo because we don't want to use planar anymore. We just wanted to collect the data and then move on from there. So we can take our part off. We're done using that. Now it's going to bring up Smart Profile, measure that data, fit it to the nominal CAD file. All right, can I read the file? Yes, the data is there. It grabbed the data, and now it's going to do a fitting to the CAD model just like our planar does. This software is actually 3D software, so it's going to take a little bit longer. Planar is pretty optimized for 2D and how to fit in the data. This is actually built in to make sure it flips and mirrors the part to get it just right. There, it wasn't happy with it, so it restarted it. But when we're done, you'll see all this GD&T. We have a profile of the outer edge held to BC. Max trigger condition of these hold held to BC as well. And we can actually do anything that is going to be on a very complex GD&T print can be calculated here. And when we're done, we see that, and we can save this as a planar, sorry, I say planar file, I'm so used to planar. You can save this as a PDF, see what these look like, see these values, and it's done for you. So the same way we run a planar file, you can run scripts in Smart Profile to do any of your complex GD&T. Now, I will say the Smart Profile is very powerful, and as we all know, powerful does come with a price. I think the Smart Profile does start off somewhere around $8 to $10 grand for the software. So it is pretty pricey, pretty expensive, but we can actually do anything to an ASME standard. You can switch it over to the ISO standard as well, and it's going to be different ways of fitting the data that you're looking for. All right, let me check my notes here to see if I missed anything. Is there any questions that you guys currently have for me? And we've all been pretty quiet, so if you guys want to take yourself off mute and say anything, feel free. So we covered most of the GD&T stuff that 2020 is going to be coming out with, and that's kind of the bigger thing I wanted to show you. So we got Scott, Christine. You guys tell me I did that good a job. You got no questions? By the way, this can be questions about just planar as a whole. It doesn't have to be anything about the updates or whatnot. You guys can feel free to send me that. Or what I'll do now is I'm going to put my email into the chat in case you don't have it already. I believe most of you should. But feel free to shoot me an email after this if you guys have questions about maybe your part specifically. There we go. Now, Scott, I know you specifically had, we worked with you on the machine that had some GD&T stuff. Can I get your thoughts on what you thought of the newer version of GD&T?
Yeah, I think it looks good. Definitely answers a lot of questions we had about what we thought it was missing compared to what we're currently using now.
Yep.
It's hard for me to go back and remember when you were here, but it definitely looks like it's in the right step forward. A lot of optimization. It looks like even for programming, when you're just setting up the planar file as well. So it definitely looks promising.
Good. This has kind of been my baby, the GD&T side, because after working with you guys and a couple other customers, I definitely disliked how they were like, well, we got GD&T, just do linear dimensions and then change it over. And I was like, that's so confusing. It doesn't look like it. Oh, and material modifiers, we can't do that. Like, so much was left out. So I was glad to finally push these guys that this is the right direction. If a lot of you guys out there aren't currently seeing GD&T on your prints, I would warn you just to get ready for it. It's going to become the new standard eventually. So I just want to make sure that, like Scott was saying, that's what other companies are doing. I think we should be doing it, if not better. And I'm hoping to get there. The only thing I'll say is we're probably never going to get to the point that we're going to be able to do what Smart Profile's doing here. There's massive calculation to do a lot of this complex datum structures and datum structures with material modifiers. I don't believe we're ever going to get there. But this is also 2D world. Usually we don't really have anything that complex. But for those that might need it, Smart Profile can do it. It's again, it's pricey, but it will help. All right, guys. Well, if there isn't anything else,
I just add to that too with the GD&T. I don't know what everybody uses it for or what companies we have presented, but it does seem like it tailors more towards people like us who have no control of the prints as well. So that's a nice thing that I see on here. We do work for everybody else, so we can't control things. So it seems like you've included enough options and enough settings and different types of GD&T that when I get an oddball drawing from company X, I can at least get results for it, because for me to ask them to change it probably isn't going to happen. So I appreciate that aspect too.
Yeah, and that was actually a lot of your guys' input, Scott. I worked with you guys to know what you guys are missing, and I saw that with other customers. So for the adaptive setting, what determines the number we should use? There actually isn't a number to know what you should use, because each part's going to be measured differently. Whether you're using stainless steel or the rubber O-rings like we had here, or even cast iron, all that stuff's going to reflect differently. What adaptive is, in essence, what it's doing is it's shifting the way it grabs the measurement data from the image that was taken. Sometimes if you up the adaptive, I don't know if this is the way it does it, just a thought, but basically think of it as it's going into the material to grab the part closer to the material side. And if you go the opposite direction, it's going to grab more part closer to the table. So you're increasing or decreasing numbers. If you increase your overall length and width, you're going more into the table. If you go more to the table, you also just made your diameters a lot smaller because you're going more to the table. So, that inverse reaction is what it's doing. But the ideal way to use it is, again, use a known standard or something to know. You could even use a caliper if you want. You could say, I want to get these overalls and my diameters as close to this caliper as possible. You could put your part on the table and start typing in. Start off with like 0.1 is a good value to start off with. Did that give you a better or worse number than you're expecting? And then you can go inverse from there to try and get that number to what you're hoping for. Now I'll say, because we're going to be measuring, everything at different times here, I wouldn't expect us to be able to nail it in within a couple tenths. Well, I mean, maybe we can get a couple tenths, but I'd say hopefully we can nail it in within a thou to the number you were hoping for, and then we can go in from there. All right, guys. Well, if there's nothing else, thanks for hanging out. Hopefully you guys learned a couple things of the system that you didn't know before, and then I'm hoping that some of you are at least a little excited for the change in GD&T that did have a lot of it. I know a couple of you that are actually here had parts with 30, 40, 50 diameters you had to call out true position to, and it was a pain in the rear, and this is what I was trying to help you out with. Is this should make your life a lot easier and get on with your day. And let's see. When will the updates happen? That's a good question. I'm hoping within the month. I've had the beta now for about 3-4 weeks. We sent it out to a couple of customers to help us test it, and I'm hoping by July we have the full release and we'll send it out to you. When that's out, if you are up to date on your software maintenance, you can just shoot me an email saying, hey, we saw that 2020 is out, because you'll see it as a pop-up in your software, and then I can send you a download link because you won't be able to manually download that via the network. It's a massive update, so I would have to just send you a download link with a new version of software, and then you're up and rolling. So perfect. All right, guys. Well, again, if you have missed anything or have any questions for what I might have missed here, if you want to review it again, this is going to be uploaded to our YouTube channel just so that other people can see it as well. And if you have anything, there's my support email there. Shoot me an email. I'd be glad to answer any questions you guys have specifically about your part. And thanks for hanging out today. Everybody take care and stay safe.